Welcome to the Data Leadership Lessons Podcast. I'm your host, Anthony J. Algman. Data is everywhere in our businesses, and it takes leadership to make the most of it. We bring you the people, stories, and lessons to help you become a data leader. We've partnered with Dataversity to provide listeners with 20% off your first training center purchase with promo code ALGMANDL. Go to dataleadershiptraining.com to learn more. Today on episode 84, we welcome Mark Herschberg. Mark is a Chief Technology Product Officer, created multiple patents, has taught at MIT for over 20 years, and wrote the book, The Career Toolkit, Essential Skills for Success That No One Taught You. Mark, welcome to the show.
Thank you. And one other thing I will add to that resume, I've also been a speaker at Dataversity conferences. I know those guys, fantastic conference, so I always enjoyed going there.
Awesome. Yeah. And we're very excited. We have more conferences coming up in person again. We're very excited about this. And yes, highly recommend for anyone who's out there. Dataversity events are fantastic. And they've done a lot of work with their online training programs and all of that. And there's a lot of free content that you can get as well that they provide and have really helped this community a lot. So I appreciate you mentioning that. And again, welcome to the show. So the way we like to start off with first-time guests is, why don't you start and give us kind of that story overview of your career and how your earlier experiences led up to what you're doing now?
I've had this really interesting dual career. I came out of MIT back in the 90s and started as a software engineer. In fact, one of my first jobs was doing OLAP systems. So big data back in the 90s before we called it big data. Now, on the tech side of my career, I have been working at traditional startups, at Fortune 500s who want to play startup. I've been through all phases of a company, lots of data projects, some structured, some unstructured. I've done ad tech, I've done data gathering on the dark web. So a lot of different things. But early in my career, I realized I wanted to become a CTO, a Chief Technology Officer. And now, of course, I'm a Chief Technology/Product Officer. And I realized that to get into that role, it wasn't just about being the best engineer. Yes, I needed those skills, but there were all these other skills: leadership, communications, networking, negotiating, team building. No one ever taught them to me. And if I wanted that job, I needed to master those skills. So I set myself out on a path to develop them. And back then, we only had books. We didn't have podcasts and websites and all these other great resources. Now, as I began to upskill myself, I realized these skills are not just for executives. They are for everyone, down to the lowest level person at your company. They're for solopreneurs and founders, and really everyone benefits. So I didn't want to just teach it to myself. I wanted to upskill my entire team, and that's what I began to do. As I was doing this, MIT had been surveying companies, and they found companies were saying, these are the skills we want to see in people we hire: communication, team building, leadership. We can't find that. Now, they're not just asking for that with MIT grads. They're not just asking for it with engineers or just with college grads. They mean everyone, but they couldn't find it either. So at MIT, we put together what's known as the Career Success Accelerator program. When I heard they were working on it, I reached out. I said, well, I have some material I've developed for my team. I'm happy to share it with you. And I thought I'd just give them the content. Instead, they asked me to help create some content for the program and then asked me to help teach. So in addition to my main career as a CTPO, I've in parallel been teaching for 20 plus years at MIT and elsewhere, and now the book, the app, and the speaking that goes along with it.
That's awesome. And you as you were talking about how we need to build additional skills to be relevant, especially at more senior levels of an organization. But I've found myself, semi-joking in conferences, especially, where I'll tell the class, I'm like, I realize you probably went into data because you didn't want to have to talk to people and you didn't want to interact with anyone but the machine. I got bad news. I'm sorry to break this to you, but what we have learned is the importance of that kind of interpersonal communication and really being able to bridge across different functions and domains in businesses, which I think is more important than anything, these days, or certainly has never been more important than it is now. What I want to talk about first, though, is you've been at MIT for 20 years. And I think back, I was well more than 20 years that I was in like undergrad and got my MBA after a while. But I look back to like undergrad especially, and I went to like kind of pretty small liberal arts university type of thing, and we tried to get these well-rounded educations. But I recall very vividly coming out of undergrad saying, I am in no way prepared for a career in actual business world. Like even the stuff that I had studied, I didn't really feel like I was ready to do anything in the actual marketplace. It was as if my university was like, we're going to teach you some stuff, but for the most part, if you don't go into academia and like grad school right away, like you're on your own, pal. Like, and that's how it felt. I'm curious, has that evolved in the last 20 years? Like MIT, obviously a well-known institution, a lot of very smart people there. Has the nature of education and from your vantage point as being a teacher and a professor in this kind of context, has that university experience evolved, or is it still focused on just the academics for the sake of academics?
Yeah, not at all, unfortunately. And it's because when you think about academia, the leading schools, MIT, Ivy level schools, they are first and foremost research institutions. And there's value in being at a research institution and the education you get from them, but they aren't practically oriented. I'm not saying MIT or the Ivy should be, but most other universities, which follow suit from the leaders, also take that approach. Now, the university system, the reason it is as it is, it goes back about 900 years, and it's run by professors. Now, professors are deep experts in their area. And for most of that 900 years, the people who went to universities, they weren't looking for jobs. You went to university because you already had money, and, well, that's what rich people do. You get that education. So you didn't say, oh, now I need to find a job. It was only really in the 20th century that the university system democratized. We think post World War II with the GI Bill in the US, and people started going. Now, back then, the way it worked is you said, okay, I want to study marketing. Great, welcome to marketing. We, the professors, the experts in marketing, have decided this is what you need to study. Take this set of classes. Oh, and the university might make you take a history or a language. They'll throw in one or two others. But if you do all these classes, we will give you a piece of paper saying you learned something about marketing. Now, they're not saying you are a good marketer. They're certainly not saying you're a good employee. They're just saying you've acquired this knowledge. And that was sufficient circa 1950 when we were cogs in a machine. When as a marketer, you'd say, okay, boss, I'm here. I have a marketing degree. What do I do? And your boss would say, do this campaign. Okay, yes, sir. Here you go. It's done. Now what? Well, now do this other campaign. And your boss would hand you the work and you sat there like a cog in the machine. If you look at the last 20, 30, maybe 40 years, corporate America shifted. We went to flatter teams. We got rid of middle management. It's no longer your boss knows more than you do and says, well, you're the grunt, so you do the work. I'll just tell you what to do and you make it happen. Now, to use this marketing example, the boss says, hey, we need to be on TikTok. I don't know what that means, but you do. Figure it out. How do we take our brand and make our brand work on TikTok? And so we're looking at teams that are multidisciplinary, teams where you're not just told, put out this work that your boss understands, but hey, team, we have to achieve this goal. None of us know how, but together we'll figure it out. And that's a different set of skills. But the university system, because it's so slow moving, has not caught up to it. I think MIT's leading it with programs like this. I've seen a few other universities. University of Michigan, for example, has a class all their engineers have to take, but it's just one. It's kind of a hodgepodge. So I don't yet see a lot of really formal focus on these skills. I will note universities about 20, 30 years ago started to say there's some need for communication. So they've emphasized some type of writing or speaking or something. But really, it's so secondary and it needs to be more paramount, really more of a primary skill included in education. It's going to be 20 or 30 years before we see that.
That's really interesting. As you were talking, I was reflecting too, as I had an opportunity to get an MBA from a top tier institution, and I think about that, and I'm like, that was really well focused on the pragmatic side of applied energy. You're expected to be an expert in something by the time you go there, especially in like the executive or part-time programs for more senior folks, but you were super focused on how do we make that relevant in the context of business and very pragmatic. I'm also going to be the first to say, I don't think you need to do that to get that knowledge. Like, that's not necessarily the most efficient way to gain those kind of real world skills. But certainly there's pockets of opportunity to get education in a formal institution that does focus on those things if that's something that you're interested in. I'm on the fence, though, as to whether or not I think the traditional MBA has a long-term relevance as we see more evolution in academic institutions. I mean, right now it's top of mind for a lot of people with student loan forgiveness and other questions around the viability of the current model of post-secondary education. It's really it's an interesting time from that perspective, so I appreciate you sharing that, even though that's not really why we're here today. It was just something that I'm like, I'm really interested in your perspective on that, so I appreciate you humoring me for a few minutes there. So I'm curious, like, you're kind of a busy person in terms of having, a senior level role that you've worked on. You've been doing the teaching at MIT, which I'm sure is no small amount of effort as well. But yet you found an opportunity to go and write a book. And having written a book, I know that that's not a small amount of effort either. And so what I tell anyone who's looking to write a book is, you got to have something really important to say, because that's the only thing that's going to pull you through all of the work that it's going to take to do this thing that's going to make you zero money, most likely. So what was it for you? Why did you write the book that you did? And what was it that you were compelled to go in and do that work for, knowing you were already pretty busy to begin with?
Good question. And for anyone thinking of writing a book, we'll put in the show notes Cognosco Media, COGNOSCO media.com/resources has a list of about 200 or so articles on every aspect of publishing. So when I went to do my book, I read about 1,500 articles. These were the 200 or so most useful on each of the different parts of putting out a book. And so I share that with other authors. For me, I didn't intend to write a book. I was spending a lot of time traveling for work, so lots of time on planes where I can kind of only do so much work. I thought, we should really write up some notes for this class. The class at MIT, it's very hands-on, it's very interactive. It's not us lecturing at the students, which is great for learning these skills, but they don't take a lot of notes. And of course, we all know how college works. The moment you walk out of the class, the information goes away. So I thought, all right, let's write up some notes for our students. I also had encouraged them, we want to share this program with others. And I thought I was writing 20 pages of notes. But 20 pages quickly became 40, became 80. And once it passed 100, I said, I don't think these are notes. I think I have a book. The book itself, I wrote it in about 4.5 months, maybe. It was really quick. Now, the caveat is I've taught it for 20 years. That was the hard part. As you said, it's having something to say, having some content. I had that. I just had to get the words on the paper. So that was the easy part. And I had to go through the book production, which is just like running any type of project.
Yeah, no, I'm glad I asked that question, because it's always such a unique journey that people have. But I think when you have that pull through, when you realized halfway through or a little more than halfway through, like, oh, I have a book. I should probably just finish the job and get that out there for folks to be able to have. And I certainly appreciate, having some additional resources. And like we always do, we'll have links in the show notes so you guys can check that out. And even if you're listening to the audio podcast, you'll be able to check out the show notes in the audio podcast as well, or on YouTube. So we'll have that.
I should note, by the way, so I began writing it for the class. Once I realized it was a book, I said, all right, this is not just for my MIT students anymore. So really expanded it. We included things that we don't get to in the class. It comes from the 10 skills in the book are the 10 skills that we see in multiple surveys by different universities of what companies want. And it's written not for undergrads, but for anyone really in a white collar job. So it's a lot more general than our class at MIT.
That's really interesting. Can you give us a little bit more? Like, tell me a little bit more about what's actually in the book, because this is just something that I think is super relevant for the audience out there.
What you get in the book and in the free companion app on the Android and iPhone stores are 10 different topics. So it's 10 topics, 10 chapters, 3 sections. Section 1, careers. Chapter 1, creating and executing a career plan. Chapter 2, working effectively, things like managing your manager, understanding corporate politics. Chapter 3, interviewing, not the how do I answer this question, you can find that elsewhere, but so many of us have to hire our peers and subordinates and get no training. So how do we actually hire other people? The second section, leadership and management, we look at the fundamentals of leadership, and then the people and process side of management. And these sections, by the way, are not just for people with senior titles. Even as individual contributors, we can use these skills to be more effective in our roles. The third section, interpersonal dynamics, covers communication, networking, negotiating, and ethics.
I love it. Like this is all stuff because I've been studying this my whole career, and I'm interested in picking this up and reading it as well. I've not seen the book before, but I am absolutely going to, because any perspective, any insight, and obviously you're coming from that kind of quantitative mindset. You're looking at the data, you're looking and researching these things, and you've been teaching the subject for 20 years. So it's, understanding that perspective is something that I think anyone at any level could benefit from. So I appreciate you sharing some of those details, because I think it'll be very useful for folks out there, and for me as well. So what I talk about, so pre-show, we talked about this happens, like, so everybody behind the curtain here, every time we have a show, and we chat a little bit beforehand, and we talk about, okay, what are we going to focus on the show, and like the show starts, and then we just go in whatever crazy direction I take it, and this is on me. Like that's just how I am. You're listening, so hopefully you enjoy it. But like that's what we get ourselves into. But I don't have a good transition here, so I'm explaining how this all happens. But I want to come back to what we were talking about pre-show, which is around this notion of communicating with data. I think that, like, I really want to understand your perspective on this, because I think this is an area that we can often overlook and may cause us no small amount of pain out in that real world in our businesses.
We have taught a module from time to time in this class at MIT. I've taught it at NYU as well, in which we take, I think it's the best-selling case study from Harvard Business School, the Space Shuttle Challenger case study. And it's known, I believe, as Carter Racing at Harvard. We modified it into Carson Racing, and we use it to illustrate the use of data and data communication. So I'm going to walk you through how this works. And this is a great thing you can do with your teams. In this module, for those who don't remember, the Space Shuttle Challenger unfortunately exploded about 90 seconds after launch. And the culprit was an O-ring. So it's this rubber ring between the booster rockets that it just got so cold, the rubber became brittle, and then you got a gas leak that exploded and unfortunately cost some lives. In this particular module, they take that concept and they put it into a race car. So you have a car and you're making a go, no-go decision. You can't just in the middle of the race say, oh, yeah, we changed our mind. Just like a space shuttle launch, there's no partial launch. There's no soft launch. So you have a go, no-go decision. And we do a couple things. We give each group of students, there's 3 different roles: the CEO, the head of engineering, and the QA person. And in their role sheets, we give them different backgrounds. The QA person has a lot of technical information, has some theories about what might be going wrong. The engineer has some perspective of that, the head of engineering, but also some perspective of the company as a whole. And the CEO, while the CEO's background is as an engineer, the CEO has all sorts of information about, well, if you pull out of the race, what's that going to do? Your investors might back out. If you race and win, here's what's going to happen. If you race and have a crash or a problem, you're going to have layoffs in the company. And that's something a CEO would know. That's not something a QA person would know. So the first thing that you get in this experience, different people have different perspectives. And all of us in our jobs have unique perspectives. We, dealing with data, hands-on, day in, day out, we understand really the models, where they're good, where the edges of the models are, and they might not be so strong, and where the data came from. The other people we present to, they just get that quick snapshot. Although they might know other things about the implications of what you're saying, and you might not have as clear a window into that. So you have to recognize everyone brings in different perspectives. Now, during this, we have data from previous races, which corresponds to previous launches. One of the things we do with our students is we don't give them all the data. We give them a clue there's more data, and they have to ask for it. And this is subtle but important. If you think back to college, for any test or problem set, you had everything you needed. The professor said, here's this week's lecture notes, and here's the test next week, and you knew what was on it. You knew what to study. In the real world, when your boss says, figure out this data model, she doesn't say to you, and here's everything you need to know. You need to figure out, did I get everything? Is there more? Someone might have something and they don't even know you need it. So learning what to ask, how to ask for it is also an important skill for us to learn as data engineers and data scientists and data people. Then one of the other key things when we debrief, so at the end we have them do a go no go decision. We talk about who did and why, and then we pull back the curtain and show them it was a shuttle. One of the things that happened during the debate, so NASA all night, the night before the launch, they were debating should we launch, and the Morton Thyrocol engineers, the contractor who built this piece, they were saying, well, maybe, and here's some data, and they're going back and forth and faxing all night. Now we have 2020 hindsight, but when I look at the slides, remember this was the 80s, so you had even I think pre-PowerPoint, and they're doing it by fax. You didn't have video sharing. You look at these slides and you say, you know what? I'd probably launch. And we see a couple things in the slides, and we'll share these in the show notes. So one is how they display the data. And they have the slide where they show the previous 24 launches, and they show 24 pairs of rockets. And they show these little marks on the rocket, some hash marks here, some stripes over there, trying to show where damage and how much it was. And you look and go, I don't know. I can't tell because it's not a clear plot. It's not displayed well, and how we display data really matters. And in fact, the other big takeaway, and it was, I'm blanking Tufte, a professor named Tufte at Yale, who is a leader in really data visualization. He did some analysis. He showed something else. If you just look at the launches where there was some data, you just plot the 7 ones where, well, there was some damage, but there's going to be some damage. It's a shuttle launch. It's not perfect and smooth and neat. And if you look at just the ones with the damage, you say, well, I don't know. I could kind of fit a flat line to it. It's not really clear. But when you plot out the ones with no damage, the ones that went okay, you look at that, and when you plot a line, and you'll see this in the show notes, you say, I don't know if it's a linear curve or poly or if it's exponential, whatever it is, but it is clearly going way, way up at those cold temperatures. I don't know how far up, but high enough that this does not look good. And it's because some people only look at just the failure cases, just part of it, and not the other modes where you get this bias. And so knowing to ask for the data, knowing how to represent the data, can make a huge difference in your story for better or worse.
Yeah, it's amazing, and it's amazing to think about how many places in that whole story, misinformation. In the case of a shuttle launch, like there's nobody there who's like secretly rooting for trouble. Like everybody there has the same intent. We want to get these astronauts to space and return safely, accomplish the mission, do those things. Everybody wants that. There's all this other noise. There's all these other considerations or what have you that stem from that and the complications of the different roles. And it really speaks to me, talking about how some of this information that was clearly really important was kind of obfuscated through the way it had been displayed. And when it didn't contain enough baseline or reference information to provide the appropriate context, people couldn't make use of it. And it goes to show like how often we share data, and this is an oversimplification, but how often we share data with one another, but without the appropriate metadata, without the appropriate context or the story around it to help people navigate it appropriately. And you mentioned Tufte. So this, for anyone who out there has not picked up a copy, it's not cheap, but it's a worthwhile read, and many libraries will have it. It's the visual display of quantitative information. Tufte's kind of like seminal book that has all of this kind of, it's a pretty big book, but this goes into much more detail than we're going to be able to do on the show about the theory behind conveying this kind of information. It's a really important book for anyone to at least be familiar with, flip through, understand, and recognize the importance of how we choose to do that. Because what you'll see too, it's one of those eye-opening things where you immediately, as you think about this, start to understand how people will manipulate those tendencies. When we see that it can be done unintentionally, and that's all around us, but when you start to see, hey, they are intentionally making us misinterpret this information, or they're starting to use log graphs commingled with linear graphs and things like that that become intentionally misleading, that's when you can, you get that spidey sense going and you're like, okay, now I know I need to dig into this more. And then it's time to ask for more information. That's such an important piece of that lesson as well. It's like, if you just knew to ask for more, you'd be well on your way to solving that problem. And it's a shame that it takes. So, I mean, Challenger is one of many examples. I've been known to watch like engineering disasters shows and stuff like that. And it's like, you learn from these, and it's a shame that these problems or fatalities or whatever occur in the first place. But it's doubly a shame if you don't learn from that, if you don't make the right adjustments going forward to make sure that those kinds of mistakes don't reoccur. And that's, it may not be life and death in our businesses a lot of the time when we're dealing with data and sharing information, but it's certainly important to try to get it right and understand how to get it right, even if you intend to get it right, but don't have the tools and techniques you need to actually execute on that.
And what we find when you watch shows like Engineering Disasters, which I always enjoy, it's not that we got the math wrong. Occasionally that happens, especially when you're pushing the edges of science. But often we get the math right. And again, with the space shuttle case, it wasn't people said, oh, we had no idea this could happen. They knew, at least some of them said, wait, we think this is a real possibility. They were unable to convey it to other people. And we have an obligation to communicate effectively. Just like when you think about vaccines or health issues, it's the doctors. I'm not a doctor. I have some basic science, but I trust the doctors to say, this is why this study is valid and why we should listen to it, because they understand it and can communicate it to us. And we put our trust in the doctors, in the researchers, in the experts. Well, people are putting their trust in us. And we're the ones who need to stand up when we see the commingling of log and linear graphs, when we see something that's not quite right, or someone taking the data and using it way outside the operating range that the model says. In fact, if you look really closely at the Morton Thyricol slides, there's a disclaimer on the bottom, and it says these slides should be considered incomplete without the oral presentation for which they go with. And yet they were passed over individually. That should have been a huge red flag. And so we, as the experts, we have a moral obligation to stand up and say, we understand here's what this is and what it isn't, and to communicate that in non-technical language to the other people who don't have our depth of understanding.
I want to pull that thread a little bit more, because I think about like the classic definition of an expert is someone who knows enough to be terrified, right? Like that's they come off as having all this depth, but for people that are less knowledgeable in that area, it can sound like they're the Chicken Little, sky is falling type of thing every direction you turn, and they may be right, but it isn't enough to be heard. And so what techniques can the expert in the room, because I imagine there's plenty of people listening to this show that may find themselves in that situation where they have the most technical knowledge about a particular subject matter in a particular room, and yet can't find the words to be heard by those folks who don't have a similar amount of knowledge. What can we do? Like, what is there a technique, or is it education of the other folks in that room?
No, it's learning, and the obligation is on whoever has the knowledge to learn to communicate to others who don't. Because you can't say, well, come back in 2 years after you got a master's degree in data science. It's not how it works. You, the person who knows data science, need to learn to communicate to your listeners. I get into this a lot in Chapter 7, but this is really for all of us. And it's not just data people, it's the finance people explaining why we're doing this type of financing. It's the marketing people who are saying, oh, well, this is why we're running social media campaigns. And if you don't understand why they're doing that instead of, say, billboards, you should ask until you get the answer that you understand. Now, I want to emphasize, here's an example of why and how it's important. This comes to me from my friend Charles Leiserson, a professor at MIT. Uses this great example that I know will resonate well with this audience. So we're going to do a little bit of math. We're going to go back to 6th grade math. I know everyone can handle it. Imagine you have a rectangle that is 4 by 10, and you will increase one of the sides by 2 units, either the long or the short. Which one do you pick to maximize the area? Now, if you need to pause, feel free to pause to think of that. But now that you're back, you know the answer is go from 4 to 6. You get 60. Okay, straightforward. What does this have to do with communicating or anything else? Well, let's think conceptually. What does that mean? When you take the 2 units and put it on the short side, it's multiplied by the long side. You're amplifying your long side. If you stuck the 2 units on the long side, you're only amplifying the short side. Now, all of us have long sides and short sides. More than 2, but we'll use 2 for this example. Our long side, for many listeners here, it's that deep data knowledge, that deep technical ability. It's really long. Our short side might be things like leadership or communications or team building. And so what happens when we think about the extreme, think about that stereotypical person who is a genius, who's that technical genius, really long, but is just discombobulated and all over the place and doesn't communicate well, and even people in the same team have trouble understanding this guy. His short side is so short, and he's this really narrow, thin rectangle. His overall area, which represents his capability, is really tiny. Now, we all need to continue to develop our long sides, especially in fields like this. What we're doing now, this didn't exist 5 years ago, and those techniques are somewhat out of date, the technologies. So we do have to keep working on our long sides, but by working on our short side, you get a better ROI. Per unit time invested, you're going to be more effective. So we want to learn, for example, to communicate better. That doesn't mean you can now deliver the TED Talk that gets 5 million views. It's great if you want to do that, but just being able to explain it without the technical jargon, being able to send a quick email that other people can follow along with. Those are the skills we're looking for communication. Go further if you want or work on your leadership. But by focusing on these short sides, we increase our overall area, we increase our capability, and that's what we're trying to do with our data skills. It's not just, well, I solved a data problem and it's just going to sit in my desk drawer. It's I'm trying to solve a real world problem using data, and that means I take that long side, but then apply that short side, that communication, to actually get a working solution that delivers value.
It reminds me of the shorthand version of that I've used in the past when coaching folks on if you want to become a chief data officer someday, you're sitting at this point where you're really bringing together the business and technology functions of an organization, leveraging data to make a business impact and all of that. And the way I said it's like it's table stakes that you can get to a CDO role, and once you get to a CDO role, you need to have some both sides of that equation, the business and technology sides. And I've seen CDOs, successful CDOs, actually come from both sides of an organization. See them grow up in an IT organization. I've seen them come from the business side. I've seen them come from legal. My advice to people who are interested in that track, regardless of where they sit today, is in your career, you need to choose. Which are you first and foremost? So in your language, what is the long side? Are you a technologist first? Are you a business person first? Decide that, and then be good at that, be excellent at that, but be better at the other side than anyone else on your side. Anyone else who's chosen that same path, you need to be as good on the other side as anyone else in your chosen path, because it's that crossover, it's that balance, it's that getting the two sides as close together as possible and having an ability to execute on both of them. That's what will make you a contender for those kinds of CDO roles or other top executive type roles in the future. So I find it interesting because I've never used the language you used, but the sentiment is the same. You have to extend the short side, and I like the way you put that.
And when you think about your roles as you move up the hierarchy, as individual contributors, we tend to deal more with people like us. I just deal with people on my team when I'm super junior. And so we speak the same language, we have the same background. I can even get by with certain shorthands, right? I can just talk about, oh yeah, we'll just throw that in a NoSQL database. Oh yeah, okay, right. When I say that to someone in finance, they say, what now? What's SQL? What's NoSQL? So I have to change what I do. But the more senior you get, the more your role involves engaging with other people, peers at your level, and working with them, not just reporting into them, but understanding what they're doing, reporting that back to your team, and working on solutions across the different departments. So this ability to translate, to speak multiple languages becomes more and more important as we get senior. But of course, one of the traps is, how do you get promoted? Well, if you're this individual contributor, you do that one little thing, you do it really well, you get promoted. And we keep getting promoted for what we did before, not always what we need to do next. And one of those biggest steps, actually, in anyone's career for any type of functional area you're in, is going from individual contributor to first level manager. Because suddenly it's not about your ability to solve problems, but your ability to get the team to solve problems. That's probably not something you really focused on before.
I've long seen those challenges on the like deep technology space, the programmers, the architects, and those folks that make that switch, because you can get pretty senior in an organization as an individual contributor when we're talking technology orgs. But I'm seeing this parallel in the data science world, where in data science you're merging this programming ability with statistics, and you're going deep. I mean, like, you're going deep on that long side. I've seen a lot of struggles for data scientists trying to make that kind of transition point. Now, is that a flaw in their approach, or is that a flaw in the role that we put our data scientists into in the earlier stages of their career? Are they just going to be ill-equipped to take that leap, or what should we be doing differently in that area?
It's probably the latter. And I suspect you've probably talked in the past about Conway's Venn diagram. You've got the three legs, so you have your data science knowledge, understanding the mathematical models that go into it. Then there's the technical ability. Do you know how to set up a Hadoop cluster, for example? And then there is the domain knowledge. Now that you have the data, and now that you can actually work with it, can you apply it to a problem? And if you only, he talks about when you only have two of the three, you might just be a hacker coming up with things, but you don't understand the discipline in which it works. Or if you don't have the data science background, you're kind of messing around with questions, but you're not really getting to relevant types of models. And so when you wind up with two of the three, it can be problematic. You really want all three, and that's the unicorn everyone looks for with their data scientists. When you think about training programs, when I look at least a few years ago, I haven't looked at them lately, especially the data science boot camps, they really focused mostly on the mechanics, the technical side. Here's how to import terabytes of data. Here's how to organize in different ways. Maybe here's how you use Snowflake. They'll get into a couple basic data science models, but usually you're not doing the effectively graduate level math that really underpins this, or at least senior college level math. They say, oh, by the way, here's a forest model, and here's a decision tree, and here's basic clustering. Don't worry about why. Use clustering in this case, but you don't get to the underlying theory behind it. And so you're not getting that deep knowledge. Yes, you can regurgitate it, fine. If I'm on an e-commerce site, let's build some clusters of customers. But when we're trying to go further, we're trying to say, how do we extend this clustering into this new business line we're getting into? If I don't understand the theory behind it, and if I don't understand the business, I'm really out of my depth. And certainly a third piece, really, I think that tends to be the weakest link. Now, part of it, you can't in a data science program say, here's one of the 100 fields you could go into. Let's learn all 100 fields. But I think people come into and they don't really learn the business. This, by the way, I talk about a lot in chapter 2, not just for data scientists, for everyone. You really need to learn the business, the industry you're in, because you're going to be so much more effective. But then even when you think about in your job, what are you evaluated on? You're evaluated on your knowledge of data science models. You're evaluated on your ability to create them technically. Rarely are you judged on, do you understand our industry? We have to emphasize that more.
It's interesting how this conversation's kind of come full circle, where we talked early on about some of the academia challenges and making it relevant. I see that same pattern with these data scientists and how they're taught to do what they do, which is a very technical, very deep area. But I see, not only do the data scientists have struggles as individuals turning that corner towards more senior level roles, and I see a lot of organizations really struggle operationalizing the output of data scientists, where it's very difficult for us to, okay, that's a great idea. CEO, here's from the data scientists. Yes, that's an amazing insight. I have no idea how to actually turn that into more profits in the end, or whatever we're targeting. And I think that that's partially because this is still, in the grand scheme of things, some new capabilities that we haven't quite fully synthesized. I also think our organizations are uniquely poorly adept at breaking down some of these silos that are going to be necessary to go across these different domains and these different functional disciplines to actually create this value that comes from data and that comes from these interactions. We're just not good at talking to each other. It comes back to like simple concept. We break these silos. Like these silos are the same silos that we've had for 100 years in terms of finance org and our operations and our manufacturing. We have a data scientist who can look across all of them, and nobody's going to listen to that person. Like in terms of how they do their particular silo, it's a big challenge.
What we've seen is similar to what we saw perhaps in the 90s. In the 90s, when the web came out, people said, "Oh, web, and we need a website." And there'd be that one nerd they hired years ago who does their desktop support who said, "Oh, I know how to make a website." And they would do that, like, "Okay, we got a website," but no one really knew what to do with it. And of course, over time, it took a few decades. And now everyone understands a website and what to do with it. And it's no longer, oh, you need that nerd to do it. Now the website's owned by marketing because it's a marketing tool. It's no longer a technical edge.
Yeah.
What we've seen in the last roughly 10 years is everyone said, big data. And all the CEOs said, "Oh, do you have big data? I ran the Wall Street Journal. Big data. We need data scientists. Can we get some? Oh, look, we got data scientists. How many do you have? Oh, I've got this many." And they just wanted it for the coolness factor. We've seen this time and again. We've seen it with "Are you in the cloud?" Not that it was helpful to them necessarily in 2007. They wanted to be in the cloud around that time. Now, yes, it's pretty standard these days. We saw it with big data. We see it with blockchain. We see it with AI ML. Just, oh, do you have this? So they threw some money and bodies at so they could tell their investors, they could tell the board, look at what we're doing. To your point, they don't understand. They have a bunch of people who are scurrying around. And now when you look at big companies, if you look at a Microsoft or a FANG company, they understand really how to do R&D and how to use this. These other companies, I don't think they have a clear approach. Are you thinking about your quick hits? Let's just do a quick model because maybe we can improve our targeting by 5%, versus here's a 6-month project that has maybe a 1 in 4 chance of actually being fruitful. In real R&D, you have a lot of failures. What's the right failure rate? What's the level of investment? What's the success rate you need to justify that? How does that tie into? So let's say it does hit the 1 in 4. Well, then how long will it take to implement that on your roadmap compared to the other opportunities you have to generate value? If it does work, how much value will it create? And no one's saying they're answering that because they generally just put all the data scientists in a pen and say, do cool data science stuff. And they're not aligning it back into the roadmap and saying, how are we driving revenue or customer value? So you're right, it comes down to this silo effect that we haven't learned to integrate data science, which has honestly a probabilistic outcome. When you think traditional product management, we're going to add this button and this is what we expect it to do. Here, we've got 6 data science projects. Some of them will work and generate some value, but I can't tell you exactly what till we get further. And we have to learn to plan and integrate better with that.
Yeah, well, and I think we're going to have to leave it there. That is such a great point, though, to close things out on, because it does kind of wrap it all together. And as we think about these dynamics, I don't know that we have a ton of great answers today, but we have a lot of good questions and a lot of good direction to head in and continue to explore as we're all trying to understand all of these complexities of data and leadership and our organizational success. So I think today has really contributed to us all kind of understanding a little bit better that world in which we live. So Mark, thank you so much for doing that. Before we go, how can people find you? What's the best way to reach out after the podcast is over?
You can go to my website, thecareertoolkitbook.com. There you can see where to get the book. You can get in touch with me if you have questions or companies who want to bring me in. You can follow me on social media. There's new content I put out on the website every week. There is the free app linked from the website to the Android and iPhone store where it has a lot of the content from the book that you can access in your pocket. And it does this passive push once a day at a time you set. So that's going to help you retain what you read in the book. There's also a resources page. On the resources page, there's other books I recommend. There's free online resources and a number of free downloads for you to use to help develop these skills. All of this is at thecareertoolkitbook.com. And then we also mentioned cognoscomedia.com, COGNOSCO media.com. If you go to /resources, there's a page for any budding authors out there. Here's all the different parts of doing a book and advice to get you going. There's also, if you like the Career Toolkit app and all the things that can help you retain there, we also have Brain Bump, which is a more generalized version that has other podcasts, books, and other content. Works the same way, but with a broader set of content.
That's amazing stuff. That's so much stuff. Thank you for sharing all of that. And like we said, all the information will be in the show notes. Check it out. I'm excited to go to look at some of it. So Mark, thank you for joining us today. Really appreciate it.
Thanks for having me on the show.
So, and thank you all for joining us today. Go to dataleadershiplessons.com to subscribe and check out past episodes and accelerate your journey with training at dataleadershiptraining.com. Stay safe during these unusual times and go make an impact.